Assalamu alaikum. Ali, how are you?
Assalamu alaikum. Can you hear me?
Yes. Can you hear me back?
Yes, I can hear you.
How was the first paper, Ali?
Yes, it went well. Alhamdulillah, I knew everything in it.
That's good. And actually, this in the month of May, always some confusions rise because some people are having chemistry, physics, bio. So some people are having maths also, na? So they are not taking classes for until the maths paper is there. Some people are having bio also. So I think it would be better if we confirm every time when we are putting a class, and especially when you mark the queries, you can always tell me that I have marked some queries, because timetable slightly hurts always every time it happens in May, because just like you had a practical, now some people are having a paper tomorrow also. Now, how you're planning the month of May?
Yes, also on Monday, like I was about to say yes.
A spring is attached at one end to a fixed point and hangs vertically with a cube attached to the other end. The cube is initially held so that the spring has zero extension as shown. The cube has weight 4 Newton and sides of length 5.1 centimeter. The cube is released and sinks into water as the spring extends. The cube reaches equilibrium. Equilibrium is actually looking to be a case of fluid with its base at a depth of 7 centimeter below the water surface as shown. The density of water is this. Calculate the difference in the pressure exerted by the water on the bottom face and on the face of the cube. The total cube size is 5. The side of the cube is 5. So if I take the top, this one, actually it is 5.1. Okay. So if I take the depth of the top surface, it will be 7 minus 5.1. It is 1.9 centimeter. I hope you can guess that this topic is going to be the topic of upthrust, because he's talking about pressure difference. He's talking about pressure difference. He's talking about the fluid, the submerged one.
So in this, we will use the rho g delta h and use
Perfect.
7 minus 5.1.
Yes, perfect. He's asking, calculate the difference in the pressure exerted by the water. So actually, I have calculated the top length and I have calculated the depth of the bottom part. Sorry. But actually, 5.1 is the point which should be considered, as you said, that pressure difference is equal to mg height difference. He has given us the weight 4. So I can replace this by 4. The height difference would be simply 5.1. Why I am taking 5.1?
Because the distance from the top to the bottom is 5.1.
Because even though we have calculated the difference, the height of the top part and the height depth of the lower part, but still you can just put the same thing. So
Won't we use like the density?
But I have written, sorry, if I made a mistake. Oh, sorry, you're right. I didn't see that. Yes, this is the calculation.
I'm getting 569.9 as the answer.
550.
569.9.
Okay. 5. 569.5. Are you getting 569.5?
Yes, because I took it, okay, I took it like 5.81 to 10 minus 2.
Yes, that's fine. So we can take it 570. Use your answer to A to show that the upthrust on the cube is 1.3 Newton. Upthrust is a force and pressure is equal to force into area. He wants us to use the part A answer. Obviously, we have a formula for upthrust, but upthrust this is upthrust. How we find the area?
5.1 squared.
Yes, we have the area 5.1. It's a square. It's a cube. It's a cube, so all dimensions are equal. 569.5.
It's coming as 1.4.
1.4.
Okay, I did it with 570 or else with 569.5, it's 1.32.
1 point.
32 almost.
Okay. Now we have to move forward to this. Calculate the force exerted on the spring by the cube when it is in equilibrium with water. Equilibrium means resultant force
Will be 0.
will be 0 and it is a force exerted on the spring by the cube. We know the working is short because it's a 1 mark question. This is the initial part of the question.
So we can use pressure is equal force over area.
No, actually, when it is in equilibrium and when it is in equilibrium, you can look on this position that when it is in equilibrium, if it is in equilibrium, it means that weight, which is downward, which is 4 Newton, should be equal to the total upward force.
Okay, so the answer will be the weight.
This is the weight. There should be a tension and there should be an upthrust. Now you can answer again if you see this situation here.
We have found the upthrust, the 1.3. We'll minus it from the weight.
Yes. We know the upthrust. Now, this is a situation. In equilibrium means resultant force is 0. So what do you guess now?
4 minus 1.3.
We can actually make an equation. It's only a 1 mark question. So we can make an equation and we can use the equation. Sorry. So what should be the answer? What answer do you suggest? 4 minus?
1.3. That is 2.7 Newton.
Yes. The spring obeys Hooke's law and has a spring constant Newton per meter. Determine the initial height above the water surface determine the initial height above the water surface of the base of the cube before it was released. Now, you need to find they have given you the spring constant, so we can find the extension. If you find the extension, you can find the difference.
Extension is coming as 0.09 meters.
0.
I took the force as 2.7.
Yes, because this is the force on the spring. Extension is coming 9 centimeter. It was, you can see now, it was at 7 centimeter depth. It went inside 7 centimeter. So how much it was above the surface of the liquid when it was dipped?
2 centimeters.
Yes, because the total extension is coming 9. The cube in the water is released from the spring. Okay, now they have released it from the spring. Determine the initial acceleration of the cube. It falls down it travels underwater, and we should see it was in equilibrium. And as soon as you release it, you have to see that it will go down due to the gravity. So what's the formula we can use? We can first find the mass, because the formula for acceleration is equal to F is equal to ma.
Mass is coming as 0.417.
Now, acceleration is equal to force upon mass. F means resultant force. As soon as you release it, you have to see carefully. As soon as you release it, how much force will be left?
As we release it, it will be 2.7.
Because as soon as you release it, spring is over. When the spring is not active, there is no tension. There is no tension. Only it's a competition between upthrust and the weight. So you have to convince the examiner that when you release it,
The final answer is coming as 6.47.
describe and explain the variation, if any, of the acceleration of the cube as it sinks in water. Obviously, initially we have done a calculation. He has highlighted the word initial. So as the cube will further go down, this is the weight, this is the upthrust. But as it goes down, another force will appear, and this is called viscous drag. The spring will continue to move down. This is the acceleration. It's a famous concept. You must have got the idea that this is the story of terminal velocity. So now you have to tell me, if you remember the famous concept, the idea of terminal velocity, that what will happen as it goes down.
Initially, their acceleration will be more, but as it keeps going down, the upward force will become equal to the downward force. So the
Yes,
acceleration
the
and
drag
resultant force.
force velocity increases, drag force increases. What do you think about upthrust? Will it remain constant?
Upthrust will remain constant.
Resultant force becomes zero. This is June 18.
This one
Use
was like An object will remain in a state of rest or motion unless an
Very
resultant.
good. It will remain at rest or it will remain in motion with the same speed in the same direction until an external force is applied on it. A block of wood, a block of weight 15 Newton hangs by a wire from a remotely controlled aircraft as shown.
Also, I forgot the wordings of the second law of motion. Like, what
The
is directly
resultant force, in A level, you have to write resultant force is directly proportional to the rate of change of momentum. Resultant force is directly proportional to the rate of change of momentum. A block of weight 15 Newton hangs by a wire from a remotely controlled aircraft as shown in the figure. The aircraft is used to move the block only in a vertical direction. This is only in a vertical direction. So it means it can go up or it can go down. The force on the block due to air resistance is negligible. The variation with time of the vertical velocity of the block is shown. The velocity is taken to be positive in the upward direction.
it the height will be like a maximum when the velocity is 0.
The aircraft is used to move the block in a vertical direction. The force on the block due to air resistance is negligible. The variation with time t of the vertical velocity of the block is shown. The velocity is taken to be positive in the upward direction. So it means for the upward motion, velocity is positive. So we have a sketch. Velocity. Actually, he has started from negative, and then after reaching the at 0 velocity, it is going upward.
So will
So it
that mean
means
the
that
minimum height or the maximum height?
no, I think there is a downward motion and then there is an upward motion because you can see velocity is decreasing to 0. This is the point where velocity is 0. And this is the upward motion. And this is the downward motion. And this is a velocity time graph. So the area would be the distance. What is asking? Let's see. Determine for the block the displacement from 0 till 3. From 0. So we can find the area. We can and
But almost from 0 to 2, the motion is downward. So we'll also count that.
no, I think I am looking for the same because he's using the word displacement. So when displacement is required, the method is very simple. Area above x-axis minus area below x-axis. So this is what I'm planning, because displacement is the vector quantity. Displacement is a vector quantity. So we have a displacement here above x-axis, and we have a displacement below x-axis. So what I was planning that if we find both the distances A1 and A2. Area above x-axis minus area below x-axis. So now you can help me out into the dimensions, the A1 and A2. So I can take 2 and 3, 1 and 3.4. And here it is. The lower area is half into 2 into 6.8.
Will we take this 6.8 as minus?
No. Otherwise, they will be added. 6.8 is obviously the speed axis. I'm taking it as a speed because in formula, if you put negative, definitely it will reach a plus then.
So by this, the answer will come negative. It will come like
You're right,
1.7 minus.
because that's fine, because area below x-axis is greater now. It doesn't matter. Let it come. He's asking for the displacement, so he's asking for direction also, no? So that's why he's asking. Can you tell me the number?
It is minus 5.1.
Okay, that's good. The magnitude will be 5.1, and the direction, as I mentioned on the graph, is downward. The change in gravitational potential energy from 0 till 3. I'm taking the whole weight.
It is 76.5.
Calculate the magnitude of the acceleration of the block at time t is equal to 2. But how I will use this formula? I don't have the resultant force.
Will it be the gradient?
I think you're right, because gradient would be a better choice. It's a straight line. It is a straight line, so we can find gradient anywhere. We can take 3.4 and 6.8. Three point four and 6.8. And what should I take for x? 0 and 3. I'm taking the full length.
It is coming as 3.4 meters per second.
It should be coming negative. Can you repeat the value, please?
It is minus 3.4.
Minus
3.4.
use your answer in B part 2 to show that tension in the wire at T is equal to is 20 Newton. Now that's a tricky part, because tension, we need to model this question, because here, and you can see what is the speed at 2 seconds.
0.
0. That's good. And we have to find this at the, we know the acceleration at this point. So where it is going at this point? Is it going upward or downward? That's the question. After 2 seconds, 2 second means velocity 0. Can you model this question that it means that initially it was going downward? It must
And then
have
it stopped.
reached the lowest point, and then it returned, and then it is going upward. What do you think?
Yes, I think it's the minimum point.
It means that this object was going downward. It reaches the lowest point. So I have modeled this like this. So then it makes clear that after 2 seconds, it would be going upward. When it is going upward, Resultant force is always greater force minus smaller force. I have made this working, but I think I have the weight. Oh, I have the weight directly. Do I have the weight? A block of weight 15 Newton. So, achha, I need mass here also actually. So what I should do? I should keep W here. I have the acceleration.
It is coming as 20.2.
20.2. The wire has a cross-sectional area of this much meter square and is made from metal of Young modulus this. Calculate the strain. Now we can think about a formula. X Young modulus is equal to FL over AE. And but I need to find strain. So I can think about a formula, stress upon strain. So we can do this one. So I have rearranged the formula. How much force should I put?
20 Newton.
20.2 we can say.
The answer is coming as 5.94 to 10 power minus 6.
10 power
Minus 6.
Okay, now read the next part. At some time after,
Won't the
some time,
terminal velocity be reached after that?
looks to be after some time after t is equal to 3, the tension in the wire has a constant value of 15. State and explain whether it is possible to deduce that the block is moving moving vertically after t is equal to 3. Now, this part requires some discussion because the tension in the wire has a constant value. It means the wire, the tension has become constant. It's no longer increasing. I can tell the examiner that this is the situation. Now, what do you suggest that if it is in equilibrium, something is in equilibrium, is it necessary that it is at rest or it can be moving?
It will be at rest.
No, it can be, but not necessary. It can be moving also at constant velocity. This is a very important concept to remember, that equilibrium doesn't mean the state of rest. Equilibrium just means zero acceleration. Equilibrium means zero acceleration, but it does not mean that the object must be at rest.
The scalar only has magnitude and vector has magnitude and direction.
Perfect. Scalar means only magnitude and vector means magnitude plus direction. That's again a very simple question is putting, that scalar or vector. So power is?
Power is energy over time, which is scalar.
Good. Temperature is?
Scalar. Momentum is vector.
Very good. An aircraft is traveling in wind. The figure shows the velocities of the aircraft in still air. So he has given us, this is a dangerous topic and it is called relative speed or relative velocity topic. So now, how we tackle such question? Velocity of the aircraft. This is called VA. VA is equal to VAW plus BW. I have shown the equation for you, and it's a head to tail situation. I just write it here, so it's a matter of recall. It's a case of head to tail. It is a case of head to tail, and I just mark here also V A W, and this is E W.
So will it be in the opposite direction?
Actually, the problem is that you have said it rightly, because the main problem is VW arrow. It is not in a good correct. It is not in a correct position. The problem is that, because we need VAW. VAW is fine, but plus VW is not fine because it's coming head to head. So what I should do first, I should extend it. And now I have got it here. Now it is head to tail. This is VA. Now it is connected head to tail. Determine the magnitude of the resultant velocity of the is asking for this. Let's look at this diagram again. And we should draw it here for
So
the
hypotenuse theorem.
no, hypotenuse cannot be used here. You know why? Because it is not a right angle triangle. You should say trigonometry. 65. This angle would be 65. You can see here, this angle would be 65.
So we can use tan 65. Like tan 65 is equal to VA over 68.
No, but why you're looking for right angle triangle? This is not a right angle triangle. This is a trigonometry case. Why don't you think about getting this angle inside first?
180 minus 65.
180 minus 65. It will be 115.
115.
I hope you remember this formula. The famous cosine rule. Oh, sorry. I was making a mistake. It's 95. Can you get the answer?
Yes, I'm just finding the last
Hmm.
part. I'm getting 47.4.
After taking under root, right? Because this number is not bad, but how it can be less than 95?
No, no, I made one mistake. I want to.
Huh, you have to check it now because it should be more than 95.
It is 109.8.
Okay, that looks good. That looks fine because logically it can't be less than 95 because 95 is one side. So that's good. And we keep it up to here. And as mentioned, we will keep on. I will try to always, as I used to, because I was a bit busy in the first 2 days of the paper, of the May, sorry. So I will keep on touch with you, and you can also update me because regular timetable should also be communicated in advance so that because you have a paper, I have all the timetables, but still I can make a mistake. Some people are having math, some people are other subjects. So we will inshallah keep it. We will inshallah do it in our next class. Allah Hafiz.
Allah Hafiz.